Cost volume profit analysis, or CVP, is a vital business tool used in many decisions, such as deciding what products to manufacture or sell, what pricing policy to follow, what marketing strategy to employ, and what type of production facilities to acquire. The topics we cover in this chapter, in particular the contribution margin income statement, are among the most important in this course. Cost volume profit analysis is a powerful management tool that helps managers understand the interrelationships between cost, volume, and profits by focusing their attention on the interrelationships among product prices, volume, variable costs, fixed costs, and product mix. The key to understanding cost-volume profit relationships is the contribution margin income statement, which separates fixed and variable costs. For the Wynn Bicycle Company, sales for the period are $250,000. Under the contribution margin approach, we separately state variable costs, which are $150,000. Deducting variable costs of $150,000 from sales leaves us a contribution margin of $100,000. The contribution margin of $100,000 represents the income available to cover our fixed costs. Once we deduct our fixed costs of $80,000, we are left with a profit or net income of $20,000. The power of the contribution margin approach comes when we state sales and variable cost on a per unit basis. If Wynn sold 500 bikes for a total of $250,000, that gives us a unit price of $500 per bike and a variable cost of $300 per bike. The key figure then is the $200 in profit per bike we make. The $200 profit per bike isn't a bottom line net income type of profit, as we still need to cover our fixed cost of $80,000. Thus, we refer to the $200 as a contribution margin per unit. Let's go ahead and see where this contribution margin format will take us. The break-even point is where the net income is zero. Let's calculate the break-even point for the Wynn Bicycle Company. We start out by making net income equal to zero and work backwards up through the income statement. Fixed costs, recall, remain constant at $80,000. Thus, in order to break even, that is, achieve a net income of zero, Wynn's contribution margin must be $80,000. The key question then becomes, at the contribution margin of $80,000 and a contribution margin of $200 per bike, how many bicycles must Wynn sell in order to earn that total $80,000 contribution margin? We find our answer by dividing the $80,000 contribution margin by our $200 contribution margin per unit, and find we must sell 400 bicycles to break even. At 400 bicycles, we'll have sales of $200,000, variable cost of $120,000, giving us our $80,000 contribution margin, which, after we subtract our fixed cost of $80,000, leaves us with zero net income, which was our break-even point. Again, break-even is where net income is zero, so we start with net income of zero. We add back our fixed cost of $80,000, which means in order to break even, we need a contribution margin of $80,000. We divide this by our $200 per unit contribution margin, and we find we must sell 400 bicycles to break even. Let's ask another question. How many bikes must Wynn sell in order to achieve a profit of $10,000? This time we start out by making our net income of $10,000. And again, we work backwards up through the income statement. Fixed costs remain constant at $80,000. In order to achieve a $10,000 profit then, the contribution margin must be $90,000. The question then becomes, at a contribution margin of $200 per bike, how many bicycles must Wynn sell in order to earn this contribution margin of $90,000? Once again, we find our answer by dividing the $90,000 total contribution margin by our $200 contribution margin per bike, and we find that Win must sell 450 bicycles to achieve a net income of $1,000. Again, to achieve a target profit of $10,000, we set our net income equal to $10,000. We add our fixed cost to our net income to arrive at a total contribution margin of $90,000. We divide the $90,000 total contribution margin by the $200 contribution margin per bicycle and find we need to sell 450 bicycles to achieve a target profit of $10,000. That, in a nutshell, is cost-volume profit analysis. In performing cost-volume profit analysis, I strongly urge you to follow the income statement approach. By modifying our approach, we can answer questions regarding our product pricing, our variable cost, our level of units or sales that we need to achieve, our per unit fixed cost, and our mix of products that we sell. Let's take one last look at our cost-volume profit analysis. This time, the Wing Company wants to know what is the lowest possible selling price for bikes if it plans to sell 600 bikes and still wants to earn a target profit of $10,000. Once again, we start out by making net income $10,000 and we work backwards through the income statement. Fixed costs, recall, were $80,000, which means in order to achieve our $10,000 profit, we needed a contribution margin of $90,000. The question then becomes, if we plan on selling 600 bikes, what contribution margin per bike must we earn in order to generate a total contribution margin of $90,000? We find our answer by dividing the $90,000 by 600 bikes. Wind must earn a contribution margin of $150 per bike to achieve a $10,000 profit. Since our variable cost per unit was $300, Wind must set a selling price of $450 to achieve its goal. Again, one more look. If we plan to sell 600 bikes and want to have a target profit of $10,000, we begin with a net income of $10,000. We add back our fixed cost of $80,000, meaning we need to earn a contribution margin in total of $90,000. We take our $90,000 total contribution margin, divide it by our 600 bikes, and find we need to earn a contribution margin or profit per bike of $150. Working back up through our income statement, we take our contribution margin per unit, add to that our variable cost per unit, which was $300, and get a selling price of $450 per unit. Be sure to work through enough problems to be comfortable with cost volume profit analysis.